Good afternoon. I'm happy to see so much people coming just for me. It's an increasingly amazing big room, biggest one for me till now. So who am I? I'm Michael. I work for innoQ. We are a small, so medium-sized consultancy based in Germany and Switzerland. And today I'm here to introduce you to Clojure. So let's start. Who of you has already read some Clojure code? Whoa, there are many hands. It's about a half of you. And who've already written some Clojure code? Okay, a little bit less. And who has deployed an application, is running an application in Clojure today? Ah, okay. We need to talk. So, what's Clojure? Clojure is basically a Lisp dialect on the JVM. Most of the people I talk to know Lisp from university, but have never seen it applied into a real system in the real world. With Lisp comes, it's a functional language. That means there's first-class support for higher-order functions, like the Java 8 stuff is backed in to Clojure from the beginning. It's dynamically typed, which on the first look may scare you away like it did to me. But when working with Clojure, you don't miss statically typing. At least I don't. And I like static typing outside of Clojure very much. The next thing I always forget to say, this is why I put it on the slides, is Clojure in the core has only immutable data structures. So there's no way for you to modify a list directly. Every time you modify something like a list or a map or a vector, you create basically a new one and have to use this return value, like string does in Java. And normally if saying this, the first hands go up and says, oh, what's about performance? What's about memory? Basically, Clojure doesn't create a new list if you add an element. So you don't have two lists afterwards, one with one element and one with two elements. The lists are modeled as basically as a tree, and you just got a new reference with a new item, which references the old items back. And every part that knows the old list has a reference pointer to this old list. So basically, it's really cheap to have immutable data structures in Clojure. And the last part is normally not the best to show in an introductory talk. But I have to because we need some of these later on. So are macros. Macros are basically some meta typing, meta stuff programming where you can change your code, but you will see. If any question arises, just try to interrupt me. I can't see you very well because it's very shiny here, but I try. So, as an introductory, let's go into a shell. Let's see where I got it. I think it's hidden here. I hope the font is large enough. A little bit slow. It runs on the JVM. So basically this is a REPL, and we can just start exploring Clojure a little bit. So let's start with the data structures. So we have, for example, numbers, 1 or 2 or 3. We have as well floats, so a float. And what's cool is we have real numbers with dividers, so we have 2/3. And it's represented as 2/3. And if we calculate with it, we can see it afterwards, it stays like this. So next stuff, we have, what do we have more? Strings. we have regexp. Okay, I don't remember the syntax, but basically this is rem. Let's switch to the slide then. I don't think it's that. So, numbers, strings, okay, characters as well. It was double quotes, of course. Regexp, basically function names or variable names, so reference names. We have keywords. Keywords, I don't know who of you knows Ruby. Basically, these are the same as Ruby. So everywhere I type double colon first, it's the same, like in Java, We have lists. Lists have these round brackets, normal brackets. And multiple items are separated by space, but if it fits you more, you can put a comma there, just to make it more appealing like a real list. And because it's dynamically typed, you can see you can mix and match, you can mix different types, of course. Then we have vectors. Vectors are basically like lists, but not exactly, because they differ where you put the next element. So on a list, it's added to the front, and on the vector, it's added on the tail, basically. We have sets, like a normal set. We have maps, basically, as known, a key, a value. You can put the comma to separate multiple entries, but you can omit it, and then it expects tuples, of course. And last but not least, we have booleans, true and false, and the famous nil. Nil is null, of course. And because I mentioned booleans, basically everything in Clojure is true except false and nil. So you can use nil to detect the false branch in an if, for example. So, syntax. You've just seen it. So this slide contains everything. Okay, too fast. This slide contains every syntax you see in a normal Clojure program. So basically, because it's a Lisp, it just handles lists. So you see many parentheses. But if you're interested, I can show you that these are not more parentheses than in a normal Java program. They just are in another place, and this looks very strange for our eye. So Rich Hickey, which is the inventor of Clojure, normally says syntax, you've just seen it. So you don't have to reserve more of your mind to think about syntax, because it's so simple. So the next thing are functions, and I can go to the REPL here again. So basically, what's a function? A function is something that's defined, for example, plus, and then you can give multiple arguments to it, and it calculates it. I hope this is right. And now you see how syntax and data structures are the same. I'm just using a list, and by default, Clojure interprets every list it sees, the first item as a function reference, and every item afterwards is an argument to this function. This is why I can't define a list like foo, bar. Okay, it's saying, okay, bad example. I can explain this later, or I will. Foo, bar. So basically, it tries to execute some function which it doesn't know exists, because the string is not. String foo is not a function. So you have to quote lists. So now I have a list. That's a little bit tricky to grasp on the first time. So next example, if I have a map, for example, conf foo is bar is foo. I can look up the value of a key by just using the keyword as a function. So besides being the same in every place, keywords can be used for lookup in maps. And I forgot to say there's no concept of classes or something like that in Clojure. So basically what you hand around in your program are always Clojure data structures. So where you would create a class person, for example, in Java, you just use a map in Clojure. So this feature comes in very handy. You can look up other type of keys like numbers or strings. It's possible as well, but this is the most common case. And then let's define a vector v with 1, 2, 3. And now we can, for example, call map inc v. And this is usage of higher order functions. I assume every one of you know how this works because you're using Java 8. Who does not? Okay. So basically, just to explain it, map takes a function and a vector or a list and applies this function to every element of the list and returns us the result. And I said collections are immutable, so if we print v here, it hasn't changed. So basically, if I want to remember this, I have to define it in another variable, for example. Okay. So the next step would be to define your own function. And for this, there's a keyword, a reference function. Or let's maybe skip this part. Or let's go to slides. That is a little bit nicer. So we've seen this. I hope nothing unexpected. Next part is about how do we define functions. And here, therefore, we use the reference fn, which creates a function. And as the first argument, it expects a vector, which just states all your variables, your input arguments. And as a second argument, you give the function body. So now we've created our own add function, but unfortunately without a name. So that would be the next step. So what we can do, because functions are a first-class citizen, we can just assign a function to a variable. So now our function has a name, add, and can be used everywhere. And because this is so common, and you see it everywhere in the Clojure world, there's of course a shortcut, which is another symbol, devn. And devn basically just take the function name as the first argument and then the input parameters and the body. So that's the shortest Clojure introductory, at least I can give. If you're interested, there are a lot of resources. Clojure.org is the site of the project Then Cognitect, which is a US company who only works with Clojure, provides the State of Clojure 2015 survey. I'm not sure if there's a 2016 edition yet. Juxt is another company who uses Clojure in the wild, which has a radar like the ThoughtWorks one, if I imagine correct. And Clojure Toolbox is basically like Ruby Toolbox. If you have a problem and searching for a library, you can just type text formatting and it shows you a list of libraries you can use for it. So, Clojure explained. Now to the funny thing, web applications. And if we think of a web application, it's basically like this. There's an HTTP request, some magic, and finally a response, which comes back. And this is just a function, basically. A function with one input argument and which produces an output. And this is why it perfectly fits to Clojure. Because it's a functional language, it's very easy to express these functions. So, if you imagine, and you've seen the syntax, how could such a function be defined? Oh, basically, it has a name, it takes one argument, request, and it produces some HTTP response. And if we imagine that could be some HTTP response, we have a status code, we have some headers, and we have a body. Done. And basically, that's what the Clojure web libraries, frameworks are all about. And the most common one, which is a library and a specification at the same time, is a ring. And what's so cool about ring is they provided the specification of what a web application means to Clojure, and everyone else in the Clojure universe agreed. So basically, every Clojure library which has something to do with web uses the ring specification. So you can change them, you can plug them together, and basically, every time you do it, it works. So, what is ring? Ring says, oh, I don't have to invent this part. There are lots of Java HTTP servers like Tomcat or Jetty. So basically, we start up there. We don't want to go to the wire below or on the top in this case. So what we define is what does a server adapter has to provide so that a web app can be plugged in. And they have 5 concepts. So the first one is they define what is a request. So what's the input parameter of my function? And they just says, the spec says it has an URI, which is, for example, /greet. It may have a query string if you have, if the user submitted one with the question mark. Of course, it has a method, get, post, put, delete, options, head. I think I got them all. And you get headers as well, the client sends. And there's a body as well, which is omitted on the slide. So basically, that's a request. So if you have a request, we need to know how a response looks like. And it basically is the same as I showed beforehand. So you set the status code, you can set headers, and you can respond with a body. And then the next part, which in the Java world, you know it from the name controller, is a handler. So Ring says a handler is something that takes a request as an input argument and returns a response, which fulfills the specification given. Nothing new. Next part, adapter. If you remember the picture, the first picture of this chapter, the task of an adapter is just to translate a proprietary HTTP response and HTTP request object to these maps. So basically, there are multiple out there, Jetty and Tomcat, of course. Then there's a generic servlet adapter, which you can plug, where you can deploy your Clojure web application to any application server out of there. And then there are a few other implementations, I guess. For Wildfly, there should be one, or Undertow to be exact. And HTTPKit is a Clojure-based implementation. So you can choose basically what adapter you want to use. The next part is middleware. In the normal Java EE specification, this is called filters. Basically, a middleware gets a handler as an argument and wraps something around this handler and returns a new function. So basically, this is a handler like I showed the Greek controller, and we return a new function which also has the signature of a handler. So it takes a request and produces a response. And in this case, I just print the request in the begin. Then I call through to the handler, but I don't have to. I could stop here and do some random stuff. I print the response, and finally I return the response. So basically, a logging filter could look like this. And there are multiple libraries which provide you with common filters. For example, to convert a Clojure map to a JSON object, or for security reasons, or for logging, or for anything else. Okay, these are the most common ones: ring defaults and ring JSON. So basically, our app afterwards looks like this. We have a Java HTTP server, we have the server adapter, the request goes through multiple layers of middleware, goes through your app, your handler, and bubbles up again. So the next question normally is, wow, we have a handler which handles one request and produces one response. Now we can fulfill a single page application, but what about if we need to deliver 2 endpoints, or 3, or 4, or 5? You get the case. And Ring has no answer to it. Ring stopped there. And the next layer which needs to be introduced is some kind of routing layer. And here you have multiple choices, because every one of these adheres to the Ring specification. And I've picked Compojure because Compojure is nice to be shown. But I will tell you the alternatives afterwards. So what does Compojure basically do? Compojure gives us DSL-like language in Clojure, which then produces a handler which takes a request and produces a response, but internally dispatches to another handler, which you can register under a given URI or for a specific HTTP method. So it looks like this. We define a handler and says this handler is for the method get. On the URI hello, we see later why this vector is there, and then you produce your result. And there I can omit this status stuff, because Compojure itself knows you're returning an HTTP response, and so if you don't specify your own status code, it sets it just to 200. And if I call this handler, so basically these are testable because it's only in a Clojure function, I can call it in my Clojure code. If I give it such a request, it produces a body, of course. And if I change the request method and use the wrong one, it just says nil. So I couldn't handle it. So this get hello, it seems like it is just a function call, but it's a macro. So we have to do a little excursion into macros. It won't hurt you, I promise. Basically, Clojure uses 2 steps to translate or to process your written source code. The first one is text. So in my REPL or in my file, I just have characters and text, which is Clojure code. And then the first thing it passes through a reader who takes this text and produces Clojure data structures. So out of this big string, now it's a list. And the second step is the Clojure takes these data structures and passes them through an evaluator, and this produces another data structure. So basically, this example is, I thought it would be a good example to show how case could be a macro. Then I looked up if it's a macro, but unfortunately internally they call to Java because of performance reasons, so this is a little bit made up. But basically we can imagine if we have a case takes an argument and then some tuples basically to see if it matches, and if this matches it returns this, if this matches it returns this, and as a default it returns the last element. And we could write a macro which transforms this to this. And basically that's all. And there you see it's Clojure the Clojure data structures are everywhere. Even the macros are Clojure code. So you're writing Clojure code which reads Clojure code and transform it to other Clojure codes. So that's the way the Clojureans work. But back to Compojure. So basically this looks like this in the end. So a function which takes a request and then it checks if the URI of the request matches hello, and if the request method matches get, and if it does, it returns hello world. So that would be the case if we unroll this macro. In the real world, it's a little bit more complicated, but not much. So I promised to tell where the vector is for. And basically, it's for extracting path variables out of the URI. So we all want to have nice URIs, of course, and you can provide this variables, which then gets stuffed here, and you can use it, basically. And because you don't want just one route, as I said in the beginning, you want multiple routes. There's a routes function or macro as well, which takes multiple routes, and basically if a request comes in, it tries the first route. If this produces something, it's done. If it produces nil, it uses the next one until nothing matched. And because this is so, you need to write this as often, there's a shortcut as well, dev routes. So as I said, it's a common pattern. So basically now our web app consists of all these steps. So below the middleware there's a routing function and some web apps. And it would be possible to even plug some middleware between these two layers as well if you need some middleware only for a few routes. As I said, there are alternatives. There's BD. BD has the advantage that it does reverse routing as well. So the first problem is to route a request to the matching handler, and the second problem is if you want to generate a link, you need the reverse routing if you don't want to hard code your URI strings somewhere. So BD solves this, and Liberator is another approach, which is basically a web machine Erlang clone. Anyone knows web machine here? Okay, so basically web machine is an implementation, an HTTP implementation, which uses HTTP RFC specifications and follows them step for step. So it checks if the URI is too long, and if it's too long, you get a callback where you can do some stuff. Very interesting. You should look it up afterwards. A little bit exotic, but very nice. So the last part before I show some code in the REPL as well is now we have all this infrastructure to handle HTTP requests, and the next step would be to provide some HTML to the user. And one library therefore is Hiccup. And Hiccup is basically a DSL written in Clojure, which takes Clojure code to generate HTML. So I specify this vector with some elements, and if I give it to Hiccup, it produces this HTML. So if you like Clojure code, this is very nice, because now you can even write your HTML templates in Clojure code. If you're a designer, you will hate it, because you are so used to HTML. I get to that later too. And because Clojurians think this is too verbose even, there are some shortcuts. So basically you can write some CSS selectors and the ID stays. And you could even use this mechanism to provide links and stuff, but to write a link, it's too noisy. So there are some helper functions like link to, which just provide this structure, which provides this HTML, of course. And the same applies to forms. So there are multiple helper functions to construct your own forms. So you say form 2, which method, which URI, and then some text fields, password fields, submit button, and so on. And as I said, now you're writing Clojure code for your HTML templates, and your designer might not know Clojure, probably. You can use some of these alternatives. Klabango, I don't remember it exactly. I know Clojure Timeleaf, of course, uses Timeleaf, which is very popular in the Spring Framework world. And Clojure, Klabango, and nlife basically is the Python Rails clone template language. I don't know the name currently. Django, thanks. And I think Selma uses another approach. Basically, it parses your HTML input, and you're writing Clojure transformations, which replaces elements with some stuff. So it's a little bit like a post-CSS transformation steps. So before we do the wrap-up, we can do some demoing. So I will close my REPL here. And we'll provide we just start writing an app. So every Clojure file starts with a namespace, DevOps app, and we need a main. So, for example, we can print hello world. And if I run this, we see hello world. So basically that's the Clojure hello world. And if we count the parentheses, there are 1, 2, 3, 4, 5, 6, 7, 8. And if you imagine a Java program, basically you have public class foo 1, public static void main 2. I already said 2, I want 1. String args. I don't count these, but we are 3, 4, 5. Okay, so be correct. 6, 7, 8. Same number of parentheses. But I always tell this joke because if talking to people, they say, oh, Clojure, all these parentheses, oh, it's so annoying. But it isn't, basically. There are no more parentheses. But what is true about it, these parentheses here tends to grow. So it's not uncommon to have like 5 or 6 closing parentheses after another. So this looks a little bit weird to our eyes. So we have an hello world. What to do next? So maybe we write some domain logic. DevOps domain. So let's say we want to have a function which returns some to-dos. So basically it's a vector with some objects, text or summary. Go to DevOps. And another one, summary, get dinner. So just a function. So if we go back, we need to import it, require DevOps domain, and I call it domain here. So you basically can rename your imports to something more familiar in your case. And now we can say println, okay, println domain get to-dos. Nothing fancy. Next step, just getting to-dos is a little bit boring, so we want to add the to-dos as well. So we can say add to-do, and I use an exclamation mark to show that this function will have a side effect. So normally you try to be as pure as possible, but to say we have no state in our program is a joke. There's in almost any case there's state somewhere, normally in the database, of course. But we are using just our memory, so it's just in convention and it's not required to add this exclamation mark here. So we say add to do, summary get to DevOps, and we add another one, more to do. Okay, so there's no magic. We have to define our own function here. Add to do, and it gets a to do item. So now what are we supposed to write here? And for this we will use a variable. So dev to dos, for example, is a vector. And this would be the first thing that comes to mind to do it that way, but it's not very idiomatic, because you can change the to-dos if you add an item, but if it's done multi-threaded, it will crash. So there's a concept called atoms, which just provides some synchronization around changing a variable. So we use an atom, which is initialized with an empty vector. And now what we want to do is, if we add an item, we want to swap out this atom with another atom. So we want to swap to-dos. And as a function, we want to conjoin our item, which basically just says, add our item to this collection. And it's in the responsibility of the collection where it adds this item. So this may be different if you use a vector or use a list or set. And we want to conjoin this item. So now we can add to-dos. And to print them, to return them, we have to unwrap the value of the atom, and this is then done by add. So add to-dos. if I've done nothing wrong. Whoosh. Unable, okay. I need to prefix it with our namespace, of course. Okay, let me cheat a little bit. See. Swap to-dos. Conjoin item. I did this live demo once before and it worked. And of course now it doesn't work. Just give me one more try. Did I save everything? Okay. Yeah, I know it. So this, because I've wrapped this add to-dos in parentheses, it tries to execute this, and we don't need it, so we have to delete it. So now it works. Line 1. Yeah. So now we can even modify our to-dos. And as a third function, let's say we need some get to do. Okay, yeah. Let's save this for later. So now we have our domain. Now let's wrap it in a web application. So web Clojure. Namespace DevOps web. And we define some index method, which got all to-dos. And returns status 200. And at the body, the to-dos. So, and in our app, we need to require web as well. And we all. And as you can see here, it seems a little bit like magic, but these stuff, so just moving parentheses around, is so common that there are multiple editor plugins, which basically prevents you from deleting parentheses by hand, and you can just say, move this parentheses to the outer scope or to the inner scope, and I use this stuff. The first day you use it, you will be very upset, but afterwards you will get used to it. And we use Jetty adapter, and here we don't import it under another name. We just refer to a specific function. So basically we import just this one function, and we won't run Jetty. So these need to be deleted. So now we can say just run Jetty, and we want as a handler our web index, and we can pass some options like the port 3000. So now if we run this, it started. And now we got an unrecognized body. Okay. Yeah, I'm not. Okay. Of course. We can't just call index with our to-dos, so we have to require DevOps domain as domain. And say domain get. I could use a REPL, but it's a little bit easier to restart. Okay, and so on and so on. Okay, and let's fix this. We need a request which we will not use. Okay, and now it doesn't need to know how to transfer this body to HTML, but we will get to this. So we can, for example, where is it? We could use Hiccup here. So we need to require it, and I will copy it from here. So basically, maybe it's easier to show just this. Big enough? Yeah, okay. So basically this is the same example, just in one file, and I also generated an ID for each item. So there's a next ID function which just increases a counter, and if adding a to-do, it not just conjuncts this item to the vector, it assigns a new item as well. And I've added a getItem function as well, which returns an item for a given ID. And because I'm not using a map, I'm using a vector, of course, I use some filter stuff here. And there's some more syntactic sugar of Clojure. So basically this construct is an anonymous function without a name. So instead of writing something like function item gleich ID item, you can just write it shorter with this, and the percent is the first and single argument, and you can say %1, 2, 3 if you have more than that. And our index could then look like this. So basically we are using Hiccup to produce some HTML5. This just adds the root HTML element. And now I say this HTML element consists of a head with a title. Then there's a body, which an h1, and an unordered list. And to produce one list item for every to-do item I have, I just use some Clojure code. So basically, I'm calling map on my items. And for every item, I produce a link to some detail page. And as a text, I will use the summary text. And this is LE, as you can see. And below that, we just put a formula, a form, to add new to-dos. What's not there is deleting or marking to-dos as done, because that never gets, I never get till that. I just add to my to-do lists. And then beside the index point, we have a save point, which just extracts the summary, which is the input, the text field you can see here, and adds another item to my list. And after adding, I redirect to the front page. And the third endpoint I have is show, and show just shows the item on a single page, and because it's only the summary, I can only print the summary here as well. And I only, of course, render this page if you've given an ID which exists. And then, as shown, you can use Compojure to compose these roots. So we have get slash, which just renders the index with all items. On post on slash, it invokes a save action, and on get with this regex or with this extraction parameter ID, it shows the page. And what's nice to see here, integer slash parseInt is just a Java function, so it uses the built-in Java integer function. So it's very easy and convenient to call from Clojure into Java, into existing Java code, by just using the slash for static methods. And if you have some instance methods, it's a little bit like this dot to string on. So basically, you're just calling the function on the left side instead on the string, and pass as a first argument the object on which this method gets called. So this is very easy, and this is the reason why Clojure supports such a huge ecosystem already, because most of the work is already done, and the only thing many Clojure libraries do is wrapping a Java library to produce a nicer to write, a nicer to read, more Clojure-like style. Yeah. And but don't try to call Clojure code from Java. This is very ugly. But this way works. And the last thing is we define our app, and this is a little bit more syntactic sugar, because normally you would write it like this. Wrap params, and in there wrap keyword params, and in this routes. So you nest very deeply, and you can see already 3 parentheses closing. And therefore they invented this threading macro. Basically, this now you can write your code below. So it takes routes, passes it as the last argument to wrap keyword params, and this construct gets passed as the last argument to wrap params. And there's even this form, which uses, I think this is the last and this is the first parameter. So just more convenience. And finally you assemble it and have your run jetty, which takes this app. And if I changed this to app and close all of these and move source devoc to do to source devox app Clojure, let's clean. I can this. Yeah, I should use Emacs as a Lisp user, but I'm used to them. Line run. So now we have this amazing to-do app. We have foo, bar, you can go into it. Feedback. And you can add stuff. And this with this exception is Chrome by default looks for /fef icon ICO, and it can't be passed to an integer. So with about 66 lines of Clojure code, you've already written this more or less complete app. So to wrap it up, as a functional language, Clojure nicely fits to the stateless HTTP cycle of just transforming basically an HTTP request to an HTTP response. Clojure usage increases, so half of you at least read some Clojure code, some of you already have written something. There are many huge companies who use Clojure and talk about it. For example, Walmart uses many Clojure in many places. In the European continent, it's not that much companies that I know who uses Clojure, so it's a little bit more complicated. Clojure favors libraries over frameworks, which is nice because you can, it's a little bit easier to understand what each stuff done. I once debugged some security stuff, and I used a library and I debugged it, and I got to the next library and to the next library, and the last library just provided one function which basically did a string equals in constant time to not be exposed to some timing attacks. And it was very easy to find out this chain. For 2 weeks now I'm debugging Spring Security, and it's not that easy. And the community is healthy and welcome, so there are about 5 to 10 mailbox entries every day. If you have questions, you get help. And with Cognitect, who has some employees who work on Clojure, I think it's ready for the future. So there are many more libraries I can't show. Lining is basically the default build tool for Clojure, which uses Clojure code to describe your build. Of course, it uses Clojure, but you can use Maven as well. Environ helps with environment variables. Root 1 is for routing and reverse routing for Compojure. I didn't show it. Your SQL is a nice extension on JDBC. And Clojure time, I told it, it's basically a wrapper around Yoda time to make Yoda time feel more Clojure-like. And I said they prefer libraries over frameworks. There are some frameworks. Basically, these are just templates and best practices how to connect multiple libraries when developing an HTTP, HTML application. So there's Duct and Luminous, or Tesla Microservices, which is from Otto. Otto is a German retail company which uses Clojure as well. And if you just need an API for your single page application, Compojure API helps as well. So basically, that's all I have. I have 2 minutes, 2.5 minutes. Any questions? Yeah? Okay, the question is about the modern way of doing REST, whatever that means, and using a Clojure script. I personally have never done Clojure script, but the idea behind Clojure script is you write Clojure code and basically transpile to JavaScript, so you can write Clojure code, which can be used on the server and on the client side as well. And I guess there's a way to connect both, but I've never used it. I know some small company in Berlin who use Clojure script as well. Okay. So I'm around here till Friday, so if you want to talk more about Clojure or prove me wrong or have some feedback, it would be nice if you come to me and speak to me. So thanks for listening.